What is the status of the other groups?
So again, like, is there any group which has like completed the data path elements? Yes.
Hello, sir.
Yes. Yoga Satvik. Yes.
No, sir. Yes, sir. I'm Nisar Upadhyay. Yes, sir. Like we are group 1. So me and my partner Animesha. So like we have not completed all the data path elements, but yes, like we have started the implementation and currently like we have finished the ALU unit, the program counter unit, the instruction memory, and we were working on the instruction fetcher decoder while and like once that is done, then only 2 units will be remaining, which is the like some part of the branching mechanism also we have completed just for testing purposes. So right now it doesn't support branch instructions, but it just like updates the program counter to the next one.
It increments the program counter.
Yeah. So like we basically first tried to get a very basic setup in place just so that we can test small things out that everything is working fine.
And did you try to play around with the block RAM?
We used for the instruction memory, we have used the ROM, so that we are using, and like we are yet to like implement the load word store word instructions. So for that, like we will use the single port RAM.
And did you see the COE thing, COE file?
Yes, yes. Like for the instructions, we are using the COE file to like initialize the instructions. So like yeah, that is also working.
Okay. Okay.
And so even our group has finished the full data path. This is Rajat Bachawat. Our group is group 46.
Okay. So did you work with the block RAM also, the BRAM?
Yes, sir. We worked with the BRAM. I mean, we used a single port ROM for the instruction memory and a single port RAM for the data memory. And we initialized the instruction memory with a COE file with an example program. And all the instructions are working properly.
Okay. Okay. And did you also like complete the load instruction, like execution of the load?
Yes, sir. We did do that, and load word as well as store word are working.
It is working?
Yes, sir. They are working.
So any group with any like issue that you would like to ask, like like there is some confusion or there is some difficulty that you're facing? Because this is the time that we are in, we are kind of face to face, so maybe it will be helpful. So do you have any questions, like specific questions on any part of the design? I'm asking in particular to those groups who are not at all communicating actually. I mean, we have not talked. I probably know some of the names by now because we have been yeah, so I got muted anyway. So so is there any other group, right? Would you like to ask any question? So it is all fine, that I understand, right? That we understand that.
Hello, sir.
Yes.
Sir, my name is Rajas and I'm from group 18. Sir, I had this problem. It's not a major problem anyways, but while using the RAMs and the ROMs, I observed that there is a delay. I mean, in the like in the implementation itself. For example, I think it's ingrained in the module. So I cannot change that in any case.
Yes.
So what this is creating certain problems when I do the store word instruction, in which I have to store it something into the data memory, right? Because that will take place in the next clock cycle.
So first of all, how much delay are you getting?
Sir, it's not a major delay, but it is significant. It is like
your delay means like in the order of what, in nanoseconds?
If I have a clock of 10 nanoseconds, so the delay is 10, I think 1/10 of that.
First of all, I would like to ask you that when you are simulating, Okay,
Yes, sir.
so in your test bench, do you have a time scale defined in the top?
Yes, sir. Yes, sir. I have a time scale defined, and it is 1 nanosecond divided by 1 picosecond.
So 1 nanosecond, not divide. The pitch is 10.
Yes, sir. Yes, sir.
Okay.
I
Okay,
got
so how much is your okay? So you are getting some delay. Okay.
yes,
First
sir.
of all,
But
let me tell you one thing. Okay,
yes, sir.
that right now when you are doing your simulation, the first behavioral simulation that you are doing, everything is assume that all the gates have got 0 delay. Okay, and if you are using a flip flop, they have got a 1 unit delay. So this is called a 0 delay simulation when you are doing the first level of simulation. Okay, but the block RAM is actually an IP core which you are using, right? And there will be a latency that is because of the specification of the block RAM or the RAM or the ROM.
Yes.
Whatever, okay?
Yes, sir.
So let me tell you one thing, that is when you are going on to do your actual post-route simulation, that means you will see that there are some multiple types of simulations, right, that are provided. So the so the final simulations, right, will have actual delays which are extracted from your design. So all the gates will have delays. Okay. So right now you are probably seeing delay only in the block RAM.
Yes,
but
sir.
you can find that
Yes,
each
sir.
of the gates that you are having in your circuit will have some delay. Okay. So what you have to basically ensure is that your circuit works in spite of those delays. Okay, and that is something which is important.
Okay. Yes, sir.
So these are usually important, and particularly this is what is called as the setup time of your design. Okay, that means if you have got a critical path in your design, you have to ensure that the frequency that you have in the clock is accordingly adjusted, basically. So there is sufficient time of the design of the input to settle to the input of your flip-flops. Okay, so that you have to verify. So right now, are you not getting correct results because of this?
Yes, sir. So right now, actually, I had made a block for the data memory, and when I was doing a test bench for that, I observed these delays. So I mean, I have to integrate the full all these data path element together, data path elements after that. But this observation,
that is a good observation that you make, and that is not abnormal. That delay will be
yes,
there.
sir. It's normal. I mean, I asked a few other people; they also seem to be getting that, so it's normal.
So you have to ensure that your circuit works along with those delays.
Yes, sir. Yes, sir.
Good question. So any other similar question or other questions? Hello.
Anybody has any other question? Students, can you hear us?
Yes, sir.
Anybody has any technical question or concern that you would like to clarify?
So if there are no questions, also you can tell that actually, okay, because we are all looking at a black screen and asking questions, right? So
yeah.
So can I just ask randomly, like some people like maybe Srishti Singh?
Excuse me, sir.
Yeah.
Actually, I had one or two questions. I was getting warnings upon synthesizing my modules. So, like, firstly, I get these modules. I get these two warnings saying that empty module instruction memory remains a black box and empty module data memory remains a black box. I have currently ignored these warnings, and I mean I don't think it affected the final simulation.
Yeah,
But
so
I'd like
Siddhartha, would you like to comment on this?
Is it something like
Hello, am I audible?
Yes.
Yes, you're audible, sir.
Yeah. So, is this error related to your block RAM instantiation?
Yes, it is. I mean, I get
So,
these
are all the
errors.
ports connected? Like, have you assigned a wire to every port?
I've assigned a wire to every port that I selected in the in the block IP generator.
And
There was
like
some,
everyone,
So what was
every of
your
the port is functional.
what was your warning? Empty memory.
it says empty module. So the name of my block RAM for the instruction memory is instruction memory. So it says empty module instruction memory remains a black box, and sits the same warning for the data
and
memory
and
module
and
as
you have loaded the COE file also, right?
well. Yes, I have for both data as well as instruction memory.
Ideally, this black box warning doesn't signify anything. Ideally,
Okay.
suppose if you are not instantiating the block RAM with a COE file, this error pops up ideally.
Okay.
Yeah.
But
So I think that is what I understand. What I gather is like this is a warning because most probably because for your block RAM there is no corresponding Verilog code. Okay. Like for all other instantiations, we have Verilog code, right? But the block RAM does not have a corresponding Verilog code. So the block RAM is basically a predefined IP that is already provided, actually, right? So it is basically telling you that it is such a design. So it is just a warning to indicate to you that to just check that whether you know that it is.
Yes, I think that's because the warning is being thrown by the HDL compiler and not by the ISC itself, I guess.
So it is basically
Yeah.
telling you that there is no, it's an empty box,
Yes,
right? Because it is
got it, sir.
just an instantiation.
Yes. And sir, there was one more warning here. I mean, it says pad symbol CLK has an undefined IO standard. This warning I get when it does the mapping part.
So most probably, I do not know whether you have done like for your synthesis, there is something called as a constant file. Okay, so in the constant file, you should define which is a clock, which port is a clock. Okay, so there should be an option like create clock, create underscore clock or something like that to tell the compiler or synthesizer that this is my clock port.
And sir, where can I find this constant file that you mentioned?
Constant file, you are using ISE, right? Xilinx
Yes.
ISE. So there is a file called UCF, user constant file, actually. Okay. So
All right.
you just do a Google search, you should get lot of
Okay, sir.
help on that, actually. Okay.
You have to create such a constant file in order. Suppose you need to find the critical part of an entire design. In your implementation stage, you need to create that
So
constant
maybe
file.
Siddhartha, we can provide them with a sample UCF file.
Yeah, sure.
Okay, so Teams will provide a sample UCF file which you can customize accordingly. Okay. Another one thing you should know that why you are defining the clock port. One of the reason is because the tool takes special treatment of the clock line because the clock goes to multiple ideally or generally it can go to multiple points, right? And therefore it drives lot of things. So if it is not properly routed, then the chip or the actual processor can get heated. Okay, and therefore it nicely kind of distributes it so that there is an even distribution. So therefore the tool takes special treatment of the clock and the reset lines.
All right, sir. Thank you.
And also this UCF file actually physically maps your port signals to physical pins of the device. So if you see the device operates at a particular voltage. So you have to mention at what voltage your design is going to operate. So that now Xilinx by default, as if you do not provide a COE file while doing the implementation, it will by default assign some particular value. So if that doesn't match, it throws that warning sometimes. So if you add a proper UCF file, it should go away.
So we will give you a template UCF file, right? So that this becomes easy for them. Or no, we can provide them the UCF file, right?
Yeah, sure.
Thank you, sir.
Any other queries?
Any group wants to show their design to clarify the design? Like I mean, it is
Yeah,
kind of frozen. It should be frozen by now, but still, if you want to.
Somebody was saying something, right? So
Yeah. Any question?
Yes, sir. In the ALU, for implementing the bit shifts, can we use assign and the operators like?
yes, you can, of course.
Yes.
Yes.
You mean
Yes.
Otherwise, we have to implement the shift.
No, you can use bit
element.
operators. Yes, of course.
You can use operators. Only thing is that internally, when it will get implemented, what will be its form is little difficult to say. I mean, the actual logic implementation that the compiler will do on FPGA, that will be slightly, but you can use. There is no harm.
So I was seeing a shift left, shift right blocks getting.
Yeah, those
synthesized.
simple operations you can use actually. There were no issues. Yeah. So I mean,
Means you want to avoid the barrel shifter. That's what you are saying.
Yes, sir.
Okay. Yeah, of course you can use
the
it.
barrel shifter, just asking, like, you had a previous design, no?
Yeah, but I think
there
we
was
have
an
to extend
assignment
that.
on barrel shifter.
Right? So is there a problem with that shifter that you had?
No, sir. I think we have to extend that then.
Okay.
And there are 3 types of shifts over here, and we have to model them.
Okay. 3 types of shifts. Yeah, I mean, a more interesting design would be if you could have done a paper pencil design. But I think keeping the bigger picture in mind, and like, if thinking about that, as long as you understand the structure, and even if you are using this left hand and the right hand shifts, right, you should be knowing that what is the corresponding hardware basically of your shifter. Okay, and inside that you can have maybe always blocks or assign statements with the shifters, but that doesn't mean that you do not know what is your barrel shifter architecture. Okay,
so that we implemented in last.
Yes, so don't basically, what I'm trying to say is that don't just keep, because you know the behavior of the block of your barrel shifter, and you should not write the Verilog code just thinking about the behavior. Rather, you should know what is the architecture, and after that you can use those constructs.
So we should write those in comments then.
No, not at all. That's not what I'm saying. I'm saying that you should know. What I'm trying to say is that you should know the organization of your barrel shifter. Okay. You should know the organization of the barrel shifter. So first of all, say draw a paper pencil design of the barrel shifter. Okay. Now you will have shifter blocks inside the barrel shifter, even if you draw the diagram. So those shifters you can implement using left shifts and right shifts. That is fine. You can use the bit operators. Okay. But don't write, like inside an if, then a barrel shifter, again inside that there are another shift. You should not write that kind of code basically. If you write, then if there is a problem, you will not be able to diagnose the code basically.
Okay.
And more importantly, see, suppose you do this barrel shifter design, and suppose you get some performance out of your shifter, right? And you are not happy with it. You would like to improve it. Can you do that? You cannot, because you have no idea about the corresponding architecture, right? But if you have the architecture in mind, right, even if you are using this bitwise operators and so on, right, you can tweak it so that it becomes better. Okay.
Yes.
Basically, think about the hardware, but write software. That is fine. But don't just think software and write software. That will be bad design actually.
Yes.
Any other group? Anybody out there? So how many of you have not seen any warnings in your design? No warnings is actually a warning. Okay. So when is the deadline, right, all of you, that the deadline is, because that is kind of fixed. We cannot change that, right? Because that is a institutional deadline.
13th. I mean, already, like we have set the deadline beyond the actual deadline. So 12th they will have the exam, 1 week from now, you will have your lab exam.
So is there any group which has not written a anything, any line of code for this design? Okay, so somebody was asking a question. Yeah, go ahead.
No, sir. We just wanted to present our report. Like earlier, sir had asked for groups.
Okay, you want to present? Go ahead. Please.
Sure. I'll be sharing my screen.
Yes, sir. This is Chapidi Yoga.
Satvik, yes, sir.
Satvik, okay.
I hope my screen is visible.
Yes, it is visible. Now it's gone.
So last Wednesday we only could show up till instruction format and encoding. We have proceeded to do the ALU design and the entire design, so I'll be showing that. Within the ALU, we have like two major sections, which is an array of 32 1-bit ALUs and a shifter unit. Like there are two different regions within the ALU. We decided to take in the shift amount, like of 5 bits as a separate input into the ALU, and it goes directly into the shifter. So the operation is also passed into this shifter, and then we get we choose whether we do left shift or right shift or arithmetic shift based on the operation input here. And just so we have one final mux, we're passing the result into these 1-bit ALUs, and the mux inside this decides what goes out, like as the final result. So we're passing the shift result from here, like each of the bits we're sending it back into the 32 1-bit ALUs as in the port shift result. So yeah, in case it's any of those operations, the result will continue to, like it'll be outputted. And we have two adding sequences that happen, like two adder circuits inside the 1-bit ALU. One of it is for computing the complement of of a number, because we need to NOT it to get the ones complement, and we also need to add 1. So we're using an RCA for this, where the other number is 0 and the carry input is 1, just for computing the complement. And then we have a regular adder that takes inputs from A and B, and the carry input is 0. Like that is one of the circuit. And we have one that computes the AND of two numbers and the XOR of two numbers. We have this third thing where we just pass in the number A. The main reason we did this was as a whole on the outside, we're sending out flags that are negative and 0, where it checks whether the result is negative or 0. This is for actually the BLTZ instruction, that is branch on less than 0. So if it turned out to be negative, the signal is passed on to the branching mechanism and action is taken place. So for that, we're just passing A through the 1-bit ALU. It's not undergoing any process, but outside in this region, this is the most significant bit, and the negative bit is being checked here. So that's how we did that. That's the 1-bit ALU and the entire ALU design. We've labeled the buses and control signals accordingly. And then here, this is the truth table for the ALU control, like based on the function code and what the ALU op from the control unit is. We have outputted the operations. And this is what actually each operation does. This ANDs or pass A so that negative and zero flags are computed. And these are for passing the shifter results. So yeah, we've labeled all of them. This is the complete data path. I think my teammate will explain it from here. Like, Seeman.
Hello. Am I audible?
Your voice is a bit low, but speak up loud.
Okay. Can you share this report again? Can you zoom in? Yeah. The input for the program counter, we actually get it directly from the branching mechanism. So we have 3 control signals in the branching mechanism. One of them is conditional branch, then register branch, and another one is unconditional branch. In case we are not executing any of the branching instructions, all of them will be 0, in which case we'll directly output the input from add4, which the add4 is a unit which adds like 4 to the program counter's current value. And then we have a 32-bit bus going into the instruction memory, which sends out various breaks up instructions. Hello, am I audible?
Yes, Seeman.
Okay, cool. So which breaks up the instructions and sends them to relevant places. We have in the register file we have 4 inputs basically. The two registers to be read, the register to be written in, and the data that has to be written. And we also have a control signal which signifies if we actually have to write into the register or not. So in the for the write register, we have 2 sources basically. So one of them is so in some of the instructions So in some of the instructions, the register is already mentioned, in which case we pass the same. And in the branch and link instruction, we actually have a special register, register number 31. So if that instruction needs to be executed, then we'll simply pass like all ones. So that's the control for that. It's called regdest, like destination register. And then for the write data, we again have 3 sources. First is the current value of the program counter plus 4, I guess. So that is again for the branch and link instruction, in which case we'll have to store the next address into the register number 31. And like the other 2 are the result from the ALU and the read data from the memory unit. So coming to the ALU, again we have so the first input is directly from the it's the data read from the register number 1, and for the second input we actually have like 2 sources. One of them is the data read from register number 2, and the other one is the sign extended immediate value. So once that is processed, we have 3 flags coming out, which will store into the which will have a register for each, and the result actually goes into the memory. It goes into the memory, and also if it needs to be written into the register. And coming to the memory unit, we again have 2 control signals, that is for read memory and write memory. Accordingly, we'll control like if it's LW or SW. And the output from read data again goes to the register file if it needs to be written. I guess that's all.
We've mentioned what the control signal does in like each of those control signals. And this is the truth table for each instruction. And yeah. That this is a report that we've submitted to them.
Okay, so this looks good. So I'm just forgetting actually. So were you the batch which showed a design where there was a feedback, combinatorial feedback? Were you the batch or it was some other batch? I forget.
No, sir, it wasn't us.
Okay. Okay. So there was a batch I remember that was showing a combinatorial feedback in one of the previous classes. So do you still have the feedback or could you solve that feedback? Anyway, maybe he's not there. Okay.
Hello.
Yep.
Yes, sir. Am I audible?
Yes, you're audible.
Yes, sir. We are the group so that we have used a feedback for the carry.
Could you solve that?
Yes, sir. We still had that in the design, but in code we thought of using a simple reg type variable for that, which simulates the same thing.
How will a reg type variable solve it actually? Because reg, I have told you this, right? That the reg variable is a data type in your Verilog writing. Okay, nothing to do with what you're doing on the hardware. So the question, right? How can you in the architecture, right, do it without that feedback? Was my question.
Yes, sir. Actually, what we thought is that we have to use the carry only in the we get the carry only in that type instruction, right? In the others, yeah, it will anyway be 0.
No, but whatever. I mean, do you still need that feedback path? That is my question.
Yes, sir. We are still using that.
But you should remove that. Okay.
Okay.
So you should work on that so that that feedback path is not required. You see, none of the batches need that, right? And you don't need it actually. So you should be able to do away with that. Okay.
Yes.
And it has got nothing to do what Verilog code you are writing actually. You should be first able to change the architecture so that you don't have that loop back.
Yes.
Okay. Any other batch? So I see if there are no more questions, then I think we are done.
Anybody has any questions, students? Good. Some of the groups who gave the demo, I think, have done a very good job, thorough job. So the other groups can also follow their example. See, if you have to devote some time behind this. Okay? If you invest some time, this is not a very difficult assignment. Anybody, any other student has any other group has anything to report? I think nobody has any further questions. So DM and SD, should we wrap up today's class?
Yeah, we can wrap up today. Yeah, okay for me. Yeah.
So next class, students, we would like to, I mean, it would be good if at least some of you could give a demo of the complete design. I mean, if possible, means you have to, like, if some groups have finished the assignment by Monday, by Wednesday, and can give a demo, that would be good. So the next class, next Wednesday's class, is basically the last class that we will have discussions, because 1 week from now you will have your exam, a lab test. So okay. Also, that is the Wednesday's class is the only opportunity for you to clear further doubts if you have before the final submission deadline on 13th. Okay, I think you can wrap up now.
Okay, bye.
Okay.
Thank you, sir.